Yeah, okay. Okay, can you guys see that?
Yep.
Okay. So, hello everyone. My name is Anastasia Rodriguez. I'm a upcoming senior at San Jose State studying mechanical engineering, and I was this summer's quality control intern. So I'm gonna go ahead and start off with what exactly is quality control. Quality control is a system that controls the quality of a product being developed. And how is it done here at Walters & Wolff? Well, it's done by identifying any defect in our entire system. In this case, we'll be focusing on the W75 Next Gen. We'll be looking at shop drawings, materials, fabrication, assembling, all the way up to the mock-up installation. And this is very important because it helps us deliver products that meet or exceed our customers' expectations, as well as it helps us achieve the lean standards that we're setting for ourselves. So the first thing I learned when coming in was how to read shop drawings. Shop drawings are very important in getting an accurate presentation of a test mockup. They show us exactly how the mockup should look and indicate which materials we're going to be needing and all the dimensions necessary. They give us all the details we need. It's going to be your best friend throughout the whole system. Here's a picture of the W75 Next Gen. As you can see, it has 7 units in the bottom and 7 units on top. So this is just an example of how I've applied shop drawings. Looking here, this is the mock-up for Mission Rock over at Shop B. Looking at the picture, we did notice that we needed some borders to hold up our panels. So I was able to retrieve all the dimensions that I needed from the shop drawings and quickly drafted up these little drawings. And these drawings just show all the dimensions and how the steel bars should be laid out. Here's the finished product of how they should look. We do still need one more corner, one more side of it. Now, another very important thing that we're going to be needing throughout this whole process is team contribution. And this is mainly done through Bluebeam, which is a software anyone could download on their desktop, iPad, or phone. And it's very important because it helps the team in identifying any mistakes that we find. And we do this by leaving comments on the shop drawings. As you can see, many of the comments are different colors. Each color does represent a different team. For example, purple could be for engineering, green could be for the drafters, and so on. As well as showing the team, it does also show which individually actually commented that comment. So you could reply to them directly through email or just leave a comment on there for everyone could see. This is just a before and after. As you can see in the after, we did fix many of the mistakes that we caught, but there is still some comments left because like I said, we are updating these as we go. Now, before we could actually start assembling the units, we need the materials. The materials are all located through the shop's PO page. Here's a picture of the PO page, and each material does have a packing slip. So the packing slip would be highlighted if the material is in. If it's not highlighted, that means the material is not in. So these packing slips are very important because they show us who received it, when it arrived, and where it's located. In this case, most of them were over at Shop B. So I went ahead and headed over to Shop B, and with the help of Ricardo, our receiving guy over at Shop B, I was able to find all of them and organize them so that when we're ready for assembling the units, we have easier and faster access to them. Here's a picture of them all organized in one place. So before we could start assembling the units, we do need to make sure that the units are going to be able to come together when we install them. Here we did a joinery sample for the corners. This is how they should be when they get installed. Here's part of one unit, and here's another unit, and here's the bridge in the middle. So we did focus on the bridge here while doing these corners. And while doing all this, we were documenting everything we found so that we can fix anything if we did found any defects. Here's a picture of something that we noted. We needed countersinks on these bridges. Here's the bridge fully assembled. Here we discussed if, since we didn't have access to this screw, we discussed if we should make it notched or we should just change the tool head. We ended up going with changing the tool head. And we were also along the way just verifying that our dimensions were corresponding to the shop drawing dimensions. So now we can start fabricating for the parts. But before we fabricate for all the parts, we start by fabricating parts for only one unit, just to test if the program is actually running properly. And it wasn't. So we did encounter some issues. This is the first issue we encountered. These need to be notched off. Those are done by hand. So we made sure to state that. Here's another issue that we encountered. There was a gap here that should not have been there. So we worked alongside with Tony, our programmer, and we were able to make this whole dimension a bit smaller so that it would get rid of that gap. So now that we fixed all those program issues, we started fabricating for all 14 units. Now we can finally start assembling the units. When assembling the units, we need two very important things. We need the unit assembly drawing and the QC checklist. The unit assembly drawing is the one up here, and it just ensures that all the parts, including the glass, are present. It also helps us in putting the parts in the proper location. It gives us all the dimensions that we need to verify. And these dimensions also help us verify that the daylight opening does correspond. This QC sheet down here is completed for every individual unit. And this just confirms that all the steps were taken properly for that specific unit. In this QC sheet, we did actually end up adding another step, which was verify that the glazing adapter is cocked for inside corner. So when reviewing our shop drawing and our assembly drawing, we noticed that the shop drawing stated that the adapter should be set in sealant, but the assembly drawing didn't. And this was an issue because the production workers do not have immediate access to the shop drawings. So we made sure to fix that because the QC sheet and the assembly sheet stays with the units while it's in the assembly line. Now here are just a few more pictures of the whole assembly process. Here's unit 7 and unit 12. We did do a little test method on it. These units are upper units, meaning they are captured. And capture basically means that they have a little cover on them. Here's an example of that cover. Later on, I will be showing you a picture of how an Inviso should look like. So for these upper units, they have an aluminum sun chair, this one right here, which needs to be placed in order for us to set the glass so that we can properly set the glass and know where it goes. So we set the chair, we place the glass, and then remove the chair again, since the head of the caulking does not fit in between the chairs. So we had to remove it, and then we caulked, tool, and then we place it back in and then finish caulking and tooling. So one of the test methods we decided to do was cut this aluminum piece in 4 pieces. So this way we'll set the chairs, set the glass, move the chairs to one side, caulk, tool, and then just slide them back into place. So we'll see how that turns out. Here are a few pictures of the whole assembly unit. I do have a document of over like 70 pages of just pictures, but I don't think you guys want to stay for another hour. So I just included a few of them. Here are some of the mistakes we caught. These headers are done by hand, so some of them were not in the right location. So when we were verifying the dimensions, they weren't lining up. So we made sure to note that down. Here's an example of how we confirm that our screws are in the correct position. We do also make sure to have the person confirming that writes their initial, because in the case that there is a leak or something wrong with that unit, we know who to contact. Here's another issue we ran into. Some of the screws weren't lining up. That was just an easy fix though. We just made the notch a bit larger and then lined it up and it was good. Caulked it, just make sure. And here's a picture of the unit assembled, but without the glass. Here's how we verified that the glass was in the proper location for some of the units. We'll use a little square on each side. And like I said, this is a picture of a capture unit fully assembled. Now, before the units could actually go out to get installed, they do need to each get individually water tested. And each one does get water tested the day after, just so that we give them enough, so we give the caulking enough time to dry. So after adding the vinyl and the pressure gauge, we began to hose down the unit, starting from the bottom to the top. And we did this very slowly just to make sure. And in the event that we do catch a leak, we immediately stop and investigate how it happened and where it happened. Here we did find a leak, but we after investigating, we saw that it was just the screw being improperly caulked. So we recaulked that, retooled it, retested it, and it passed. So each of them do need to pass in order to go to get installed. Now here's a picture of the mock-up out over here at shop A. These are the 7 lower units. We do need to test them first before we could actually add the upper 7 units. And this is just an example of the Invisos. So like I said previously, these don't have that little cover on them. These, you can see the sealant. So here in this mock-up, we're trying new things and testing the zipper mullion, the bridges, and the corners. Here's the bridge. So one issue we ran into was that this gasket over here was not bendable enough to slide right into the bridge. And our solution was just to cut it and caulk it, and it worked fine. These are the steps we took on how we installed it, and this is how it should look. And this took approximately 20 minutes to install, which is quite a bit of time. So we are looking for ways to reduce that time. Now, like I mentioned, once they do get installed in the mockup, we do perform multiple tests on them. An example of a test that I was able to be part of was the racking test. This racking test, we wanted to see what would happen when we moved them side to side. One of the things that we wanted to focus on was the zipper mullion. The zipper mullion is located right here behind these 2 units. So it gets attached between the 2 units. And we wanted to see if the units would move side to side and act as one unit, or if they would act as one large unit. If they were to act as one large unit, that could cause a problem, because that means that this unit over here will be getting the load of 2 units instead of 1. So here is how the zipper mullion is originally designed. These holes, as you can see, they're very tight. So we expected that there wouldn't be enough room for these units to slide, but we still wanted to test it just in case if it did work. And so we tested it and it didn't work. So we made the hole a bit larger, 1/4 inch to be exact, but the unit still did not move. So then we decided to add a slot on one of the sides. And although we did get a little bit of movement, we didn't get it to move how we wanted to. So we finally decided to add slots on both sides. And this as well also did move a little bit, but it didn't move how we wanted to. So we are going to have the Diama make the slots for these so that they're much smoother. And then we will retest. We do also have to retest with the cover on these zipper mullions. But on the other hand, the typical units did do what we expected. They had a vertical offset of about 3/16 inch. These are the typical units. So on top of the next gen, I was also able to apply my lean thinking through SOPs. While looking for a new SOP on the shops page, I noticed that some of them were not opening up. So I decided then to go through all of them and noticed that there were quite a few issues that I encountered. So I created this system to help improve our homepage. So over here, this is a sheet that I made on Teams. These are all the SOPs are on our homepage. And then I just made sure to write the comments, that all the comments that I found, some of them were duplicates. A lot of them were the old template. Some of them were just basically missing the step, missing the numberings for the steps. And just so that we don't repeat this issue, we made sure to add a column here so that whoever's working on that SOP writes their initials there, so that not two people are working on the SOP, so we don't end up with duplicates again. And with the help of the team, it's been going great. We've been improving a lot. There's a way more greens than reds now. And on top of that, I was also able to work on my own SOPs. So I was able to work on the Shop SL Rack SOP, the Inspection Cam SOP, which is a little camera that we use to inspect spaces that we can't reach, dark or tight spaces. And with the help of Miguel, I was also able to learn how to use a 3D printer. So I was able to update the unload and load filament SOPs. And speaking about 3D printing, I was also able to help design and print out little tools. The first tool was the interior toolbox drawer retraction finger pull. So this is a little tool that the interior team uses. And the problem with that one was that the one they had was very fragile and would break very often. So I decided to get all the dimensions, design it on CAD, and print it out with a much stronger filament. And so far, it's been working good. The next one is Shop A's SL rack. This is the rack over at Shop A. And the problem with this one is when you pull this rack out, if more material is on one side, it will cause it to be unbalanced, making it tip over. And since there's no support on the sides, it's basically going to fall on someone and can cause damage. So our solution was to add this outrigger with these little clamps. And when designing this clamp, I made sure to make it a bit larger than the outrigger itself, since these racks, some of them are not all straight, they're tilted. So even if it's tilted, the outrigger can still easily slide in there. And this is the finished product. The finished one is made out of steel and welded on these racks, because if we were to keep this 3D printed clip, it would not support this rack if it were to fall down. The last one is the multi-cam clamp. So this is a clamp that they use on the multi-cam to hold these panels in place. So the issue with this one was that every time you'll tighten this clamp, this nut will pop right up. And we had a solution to that. We could easily just glue them down, but there are like 10 of these. So that's not very lean of us. We're adding an extra step that we shouldn't need to do. So I redesigned it so that there's a little slot here so the nut could just slide in. So even if I were to tighten this, there's no way that nut can pop up. So that concludes my presentation. Any questions?
I like the fact that both of you had, in your internship, had looked at something and worked on something to help with safety, such as you helping Ray with those stock length racks. We had issues with that forever as we added more material on it. And so it was a pretty easy fix with that outrigger of how it clamps on and the safety of it now for the employees. That's really good too. If I had a question, I would say, what is the one biggest thing that yourself, Anna, that you were able to work on that helped you in your internship through the couple months that you were with us?
So I was able to learn a lot of new skills that I didn't think I was going to be able to. Just coming in the first week, I got to learn how to use Inventor, how to use AutoCAD, and these programs are stuff that we don't usually use at San Jose State. We stick to SolidWorks, and so it was nice learning a lot of more programs that could help me design in my major.
Nice. I'm glad that worked out.
Is there anything we could have done to make your internship better?
No, I think it went great. Like I didn't think I was going to be able to learn the whole process, starting from the shop drawings all the way to actually seeing the panels, the windows get installed. So I think that was great, and that I was able to learn them. Like these shop drawings also, we do have some, I have seen some at San Jose State. We do, when designing, we do print these 2D drawings out, but they're never as in depth as these ones are. So it was great learning that.
Nice.
I have to say that Anna is a very quick learner. We spent maybe 2 or 3 hours going over like just window nomenclature, and she picked it up very well. I mean, most people don't know what a mullion means, what a glazing adapter is. She picked it up. I mean, I even heard one person one day say they thought a glazer was somebody who made donuts. I mean, but no, she handles all the concepts. She works well with fellow employees. I said, there's going to be times where you're going to have to tell somebody, hey, you're doing that wrong, or you got that backwards. I go, don't be afraid to say anything. I go, these people that you're going to be working with are all nice. They've been here a while. They know the drill. So just speak your mind when you want to. But I'm really happy that she works with us, and I hope her future's even brighter. Thanks, Anna.
Thank you. I just want to say thank you to everyone for letting me have this opportunity. Like I said, I've learned so many new skills that I didn't even think I could in these short months. And like this, this means that you're telling me in this internship, I don't have to make coffee. I actually did get to learn a lot of things and do a lot of hands-on things. And it was great.
Nice. We're really glad you're here and glad Alec was here. You help us learn as much as we help you learn too. Very detailed for very young people and still in college. So it's great.
Thank you.
Okay, that was it. We could have had a little more attendance, but you guys did a great job for us, and look forward to seeing what else you guys do in life.
Good job.
Yeah, thank you so much.
Thank
Good
you.
job.
Thank you.
Great job.
You guys, bye.